Okay, let's jump right in. Have you ever been stuck trying to convert octal numbers to binary? It can feel a little slow and clunky, right? Well, today, I'm going to show you a trick that is so fast, it'll completely change how you do these conversions. Get ready for the 3-digit shortcut.
So, picture this. You're looking at the octal number 345, and you need to get it into binary. Now, you could go through a bunch of steps, maybe pull out a calculator, but what if there was a way to just look at it and see the answer almost instantly?
You know, the traditional way to do this is to take your octal number, convert it to our normal base 10 decimal system, and then take that number and convert it to binary. And sure, it works, but man, it is slow, and there are so many places to make a tiny little mistake. We are going to skip all of that. All right, section 1, let's introduce the shortcut. We've talked about the slow way, now let's get straight to the good stuff. This is where things get really cool and, honestly, pretty clever.
Okay, so here's the absolute heart of the trick. You have to remember this one thing. Every single octal digit corresponds to exactly 3 binary digits. Not 2, not 4, it's always a group of 3. This is the simple, powerful idea the whole shortcut is built on.
So you might be asking, why 3? Why is that the magic number? Well, it all boils down to some really simple, beautiful math. Binary is base 2, right? And octal is base 8. The relationship between them is that 2 to the power of 3 equals 8. That little equation is the secret key that makes this whole thing work. It means one octal place holds the same amount of information as 3 binary places. Okay, so now that we know the why, let's get into the how. In section 2, we'll cover what I like to call the 4-2-1 method. Seriously, think of this as your personal cheat code for doing these conversions in seconds. So let's go back to that first number, 345 and octal. The most important thing to do first is to stop thinking of it as 345. Instead, I want you to see it as 3 separate digits, a 3, a 4, and a 5. Now, for the magic key. Under each of those individual digits, you're going to write the numbers 4, 2, and 1. Now, where did these come from? It's not random, I promise. They are just the first 3 place values in binary. You've got 2 to the power of 2, which is 4, 2 to the power of 1, which is 2, and 2 to the power of 0, which is 1. That's it. That's our key. So let's start with that first digit, the 3. Just look at your key. 4, 2, and 1. Which of those numbers do you need to add together to make a 3? Exactly. It's the 2 and the 1. So we think of these as on and off switches. Do we need the 4? Nope, so that's off. We put a 0 there. Do we need the 2? Yes, so that's on. We write a 1. And do we need the 1? Yep, that's on too, so another 1. And just like that, the octal 3 becomes the binary group 0, 1, 1. And now we can just fly through the rest of the table. For the octal digit 4, how do we make a 4 with our key? Well, we just need the 4. So that's on, off, off, or 1, 0, 0. And for the 5, we need a 4 and a 1. So that's on, off, on, which gives us 1, 0, 1. See? Each digit just maps perfectly. And here's the best part. Are you ready for this? The final step is, you just stick them together. That's it, no more math. You just line up those 3 binary groups, and there's your answer. 345 in octal is 0, 1, 1, 1, 0, 0, 1, 0, 1 in binary. How easy is that? All right, section 3. See how fast that was? Let's do one more just to really lock this method in your brain and prove that it works every single time, no matter the numbers. Okay, let's try the octal number 105. And remember the rule, right? We're not looking at 105. We are looking at 3 separate digits, a 1, a 0, and a 5. The process is exactly the same, and it's lightning fast. Step 1, you write down your 421 key. Step 2, you convert each digit one by one into its 3-bit group. And step 3, you just combine them all into the final answer. So for the 1, that's easy. We just need the 1 from our key, so we get 0, 0, 1. For the 0, it's even easier. We don't need any of them. So that's just 0, 0, 0. And we already know the 5 from our last example. That's a 4 and a 1, which gives us 1, 0, 1. Now you just smash them all together, and there you have it. 105 in octal is 0010, 00105 in binary. Seriously, once you have that 421 key memorized, these conversions take just a few seconds. So let's wrap this up with section 4, why this shortcut works. Now that you've seen how to do it, and you know it's reliable, let's just do a quick recap of the why. Because when you understand the reason behind a trick, you'll never forget how to do it. It all comes back to this one simple piece of logic.
The whole system exists because of that direct mathematical link between base 2 and base 8. That relationship, 2 to the power of 3 equals 8, creates this perfect, clean grouping system. One octal digit just naturally holds the exact same amount of value as 3 binary digits.
And that's really what's so cool about this. It feels like a magic trick, doesn't it? But it's not magic, it's just math. It's a beautiful, simple reflection of the logical structure that connects these number systems.
So, I'll leave you with this final thought. We just taught our brains to think in threes to connect octal and binary. It kind of makes you wonder, doesn't it? What about other number systems? Think about hexadecimal, which is base 16. What's its relationship to binary? The patterns are out there, just waiting for you to find them.